After finishing it, you are, suppose, if you want to drill there, you can drill. But that is, after manufacturing the article. And that's why this is a tertiary processing methods. Or maybe you want to weld something to your original part. That is also a tertiary process. These are the basic idea about the classification of the processing methods on the basis of primary, secondary, and tertiary steps. Now, the fundamentals of processing. What are the fundamentals of processing? Performance requirements. Now, what type of requirements are there? If you want to find out that performance, in which basis, engineering approach or a practical approach? There are two type of approach, engineering approach as well as practical approach. After that, we have to select the materials. By finding the approach, then you have to find out the material. Then once you find out the material, there are three steps. You have to, how you process that material. What are the properties of that material? Because if their properties are not good, then how can you process that? It is not stable to heat. Then how can you process that? Therefore, properties are very important. Then, the very important factor is the cost. The cost is the main factor, friends, because it should be, that you should get some benefit out of that. Otherwise, if you don't get the benefit, how can you, that process all the shaping of the polymers? Not possible. And that's why the cost is a important factor here. And whatever your ideal choice, what type of material you want to process, maybe injection molded article, compression molded article, transfer molded article, calendaring, that any type of process you can select and you can go ahead. These are the fundamentals of the approach
What
for
is
the
calendering? What is calendering?
calendaring also.
Calendering.
Yes.
What is that? Can you please
Calendaring is a process. It is a continuous process, right?
can you give me? I'm not aware about calendering. Can you please explain if possible?
Yes. We have that topic, friend. We have a complete 2 lectures on calendaring. Don't worry. Uh, we will
Great, great,
talk.
great, sir, great, sir.
Yeah. We will definitely cover everything about the calendaring. Don't worry. I myself work with the calendaring plant. That is in the 90, no, 1989 in Bhor industry. That was a Bhor industry here in Mumbai, Bombay, at Borivali. I have got job there and I work with the calendaring plant. Therefore, you will get all information about the calendaring plant. Don't worry. Now, the processability. Everything is there. You have selected the product, you have done the everything, practical approach, engineering approach. You have done everything and you are coming to the other articles. Now, the processability is very important, friend. It is generally very difficult, right? See the plastic, there are different type of plastics and how they fabricate, how you create the film. There are two process, maybe extrusion or maybe calendaring, right? Even molded parts, molded, no, that extrusion, pipe extrusion, right? Therefore, processability is very important. The material should be, after process, you should get a pipe, right? The material should be able to process for the pipe, for the injection, articles like that only. Therefore, we have to create the material property to achieve our final product. A plastic with a good processability possesses the properties necessary to make it easy to process the plastic into desired shapes. The friends, processability is a very important part of the plastics. Without that, you can't flow the material into the machinery. And that's why whatever the shape, maybe, a complex shape article you can manufacture by using a specific, the material which is easily processed or easily flow. Such a material will identify for the injection molding purpose. The main characteristics or properties which determine a plastic's processability, which are the governing factors which affect the processability, that is molecular weight of the polymer, uniformity of the polymer, the types of the additives you are using in the compound, and the contents. What are the contents you are using? What type of? What is a 2%, 3%, 5%, 20% like that? You are using the additives, but what percent? That is also you have to think about that. Then plastic feed rates. How you feeding the material into the hopper to the machinery. Therefore, friend, molecular weight, the structure of the polymers. These are the very important properties for to decide the final physical property of the polymers. Therefore, here the processability, which will affect by all these factors. If the molecular weight is very high, then processability is not easy, friend. It's a difficult process. Therefore, the molecular weight should be suitable for the machine and to create the easy process. Therefore, processability, it depends upon the molecular weight. For example, if you see Teflon, polytetrafluoroethylene, it's difficult to flow. If you see ultra high molecular weight, high density polyethylene, it have also high molecular weight and therefore very difficult to process, friend. It is not easy to process on the simple injection molding machine. Uniformity. You know that you have seen that in plastic materials, different type of structures are there. The structure may be linear, maybe having the branches, maybe having the network, a complex shape of the polymers, right? If you see the three-dimensional structure of that, it is a very difficult to process. Therefore, their structure will affect the processing and that's why the final properties and the quality of the product. If you see the additives, that also affect the properties. What type of percent you are using the additives? What type of additives you are using for the process? That also, there are, the additives are like our tablets. See the patients who are taking the tablets for fever, for cough, small. If you see the same thing happening here also in polymer. We have to add additives. Additives are nothing but the vitamins for the plastics, right? You have to add the right additives for the right polymer. It should be compatible with the polymers. Then you will get the final quality product. Now, the processing methods. Depending upon the configuration of the part, economic viability, and the part tolerance, the process can be selected. I told you already, economic is a very important thing. Cost is a very important thing. Then part size, whatever part you want. You want a single article, you want to a complex article, you want to a complex design, you want to a continuous profile like a wire, like a cable, like a pipe, what type of article you want, what type of volume you want, the size, shape of the article will affect the process. Therefore, depending upon the final shape of the article, structure of the article, you have to select the process to process to shape the polymers. Now, machine operation terminology. manual operation. Each function and the timing of the each function is controlled by the manually by the operator. That means you can control anything, anytimes. The manual operation. Semi-automatic operations. A machine operating semi-automatically will stop after performing a complete cycle of a programmed molding functions automatically. Those are working on the injection molding machine. They know that in a semi-automatic machine, we have to only open the gate, article will fall. Otherwise, article will fall first, then open the gate, take the article, close the gate, finish. The next cycle will start. Automatic operation. Now here, you not need to do anything. Just it is going on. It is automation in the process. Now processing method, the types of process to be used depending on the variety of the factors, including the product shape, size, plastic types, quantity of the product, quality, accuracy, required design and performance, and last, the cost limitation. These are the very important factors. Each of the process provide different method to produce a different product. For example, extrusion with its many methods, film, pipe, sheet, profile, wire coating. These are all done by the extrusion process. Almost all processing machines can provide a useful product with a relative ease. And the certain machines have the capability of manufacturing a product to very tight dimensions and performance. Therefore, the coordination between plastic and machines should be very important, which will facilitate the process. Now, plastic materials that you know very well, thermoplastics, regular pellets or granules, and can be remelted. Thermostatic materials. It start as a liquid also, syrup also. Often we are also uh, in the market resins, PF resin, urea formaldehyde resin, phenol formaldehyde resin, epoxy resin, diallyl phthalate resin. There are very few resins are there, thermoset materials, partially cure product that is called as the preforms, which need to heat for the final shaping. The shaping is accompanied by the chemical reaction, which means that the material does not soften on a reheating. Once it in a first state where material soften, but when you reheat, the material can't that soften. The reaction may be exothermic, giving heat out, in which case cooling is required, friend. Now, plastic processing methods. Somebody asked just now what type of that the schedule. Yes, schedule is ready. We are going to covering all extrusion process, injection molding process, blow molding, stretch blow molding process, thermoforming and vacuum forming methods, compression molding, transfer molding, rotational molding, casing and slush molding, calendering, reaction injection molding. If the time permit, we are going to see some machines part also and some auxiliary equipments, some hydraulics to require for this to operate these machines. We are going to see each and everything about the processing as well as some machines also. Now, friend, today we will start the compression molding process. First, we will complete the compression molding and then we will start the transfer molding process. Now, what is the compression molding process? It is a two-step process, friend. First, you have to preheat the material, the preheating of the material and pressurizing the material. Therefore, friend, in compression molding, if you see here, this is a simple mold is here. This is a platen which will holding this upper part of the mold. This is the bottom platen, which is also holding the lower part of the half of the mold. And this mold is in open condition now. This is a mold. This is a mold. This is a platen, upper platen and lower platen. Upper platen, which is holding the movable mold half mold. This is the bottom. This is the bottom mold. The mold have a two half, upper and lower. Therefore, it is get fixed with this bottom platen. And here is the ejector pin is here. Ejector pin. Very simple mode here, friend. Now this green part showing a charge. That means raw material. It may be in a specified tablet form, maybe in round form, maybe some tablets are there, maybe some powder, maybe they are charging. But before that, you have to take the weight of this before putting here. Right. Now see the mode is in open condition. You are charging the material here. Okay. Now see the green, this portion, it is a material, raw material, maybe in pellets, maybe in tablets, maybe, in a specified given form. Now after that, after closing this, see now, it's closed. So this is ejector pin. Now this is now in the a simple mode is there. After closing, you will get the article. Therefore, here, this before this, if you see, this platen is heated. This is the mode having some here. This part is here having, the heaters are there. You have to heat this first. This both one, upper and lower mode. So, friend, this is a simple principle for this compression molding process. We will go everything now here. Now, what are the material used in this process? Many people are saying that only thermosets are used on the compression molding process. But also, if you want to sheet, plastic sheet, a small sheet, maybe 1 feet sheet, you can also manage process here. But you have to, additionally, you have to, uh, the mold should have heaters and cooling systems. Then it is a possible. You have to alter something. You have to insert some, cooling in the mold, and then it is a possible. The friend, thermosetting polymers. You know very well which are the thermosetting polymers: phenolic resins, amino resins, epoxy resins, diallyl phthalate, any other remaining? Very few are there. And polyester resin. Which polyester? That is an unsaturated polyester. Now, what is a phenolic resin? Phenolic resin have two types. One is novolac resin and second is the resolved resin. Right. Novolac resin we are using in a compression mode. Resolved resin we are using in the for lamination purpose. If you see amino resins we are using here urea formaldehyde and melamine formaldehyde. These are the two amino resins. Third one is epoxy resins. We can also use epoxy resin for this process. Then polyester. Which polyester? Unsaturated polyester. This thermostatic resin. Saturated polyester is a thermoplastic resin. Remember this thing. Therefore, unsaturated polyester, which is a thermosetting resin, can be processed on the compression molding process. Now, friend, here you may be having three types of the thermosetting resins. It is divided into three types: A stage resin, B stage resin, and C stage resin. What is the A-stage resin? A-stage resin means a completely pure novolac resin or maybe phenol formaldehyde resin, pure, without adding anything. Just reaction of phenol plus formaldehyde. You are getting the product of phenol formaldehyde, maybe a novolac resin. Okay, it is in powder form. This resin is called as a A-stage resin. But if you add filler ingredients, maybe you know that different type of ingredients, fillers, plasticizers, stabilizers, heat stabilizer, antioxidant, acid. There are many uh, ingredients we're adding in the polymer. That ingredients and this pure polymer, when you mix that, that is called as a B stage resin. That means resin plus additives. This is called as a B stage resin. Now, what is meant by C stage resin in a thermosetting polymer? C stage resin is nothing but whatever you are getting in the B stage resin plus all additives. You are mixing that, making a powder of all these ingredients, and with resin mixing that, compounding करते हैं हम लोग. After compounding, you are molding on compression molding press, transfer molding press, and after molding, that article you are getting, that article is called as a C stage resin. Therefore, any thermoset have a three type: A stage, B stage, and C stage resin. I told you, A stage means pure polymer. B stage means polymer with additives. And C stage means after molding the B stage resin plus additives, you are getting the final product. That product is called as a C stage resin. Now, friend, fiber reinforced composites. These are also the materials can be used in a compression molding press. And lastly is thermoplastics. I told you just now, high molecular weight polymers, the material which have a very high viscosity and very structure is very viscous after melting. They don't have a flow at all. Such a polymer, such a polymer can be processed on a compression molding press. Therefore, here ultra high molecular weight polyethylene and long fiber reinforced thermoplastic, maybe polyester resin, can be processed on this compression molding machine. Now, what is the compression molding actually? I told you, usually used for the thermoset compound. Molding powder or a preform. What is a preform? What is a powder? Powder means just like, very fine powder, maybe like rava, right? Very, very, very fine. Preform. What is a preform? You are converting that powder into tablets, maybe in a cube shape, maybe in a round shape. That is called as a preform. Therefore, it is a very easy. Why we are converting powder into preform? Because it is a easy to pass into the mold. Second thing, we can add the accurate material, maybe 4 tablet per shot, like that. maybe 6 tablets per shot. Therefore, there is no wastage of material. And that's why we are using a preform, that is a tablet or maybe tube type shape preform. We are converting, I told you, the powder into the preform. I will show you, I have one video how they making a tablet. They have made there a powder converted into the tablet. I have video, I will show you afterwards. Now, this preform, they are positioned in a heated mode. I told you have to first hit the mode in compression molding process. The mode is closed with the application of heat and pressure. The material flows. See, after closing the mode, material start to soften due to the heat and the pressure. The material flow into the mold and fills the mold cavity. Spread होता है and it will fill the cavity. Heat complete the polymerization and identification the part of the ejector. So friend, after that, you can remove the article when the article become a dense. Now here in thermosetting, we are heating the mold. We are not cooling the mold here. Now, what type of product can be manufactured on the compression molding process? Plugs, sockets, handles, engine, casing switches. There are many things, friend. Buttons, you know, if you see the old switches in the railway, that also manufactured by using the compression mode. Heat complete polymerization. So, friend, here polymerization takes place only by heating. And after that, once the polymerization complete or reaction complete, the part is ejected. The process is sometimes used for thermoplastics. Example, vinyl phonograph records. Now, what are the advantages of this process? Little material waste in the attainable because we are using the preform or tablet. Large article you can manufacture, bulky parts can be molded, and the process is adaptable to rapid automation. Now, what are the limitations of this compression molding process? Extremely intricate part containing undercuts, not possible. Complex article you cannot manufacture on this a process machine. Side draws, small holes, delicate inserts, not possible. Very close tolerance type of articles, difficult to produce. And it is also a time consuming because it requires a different, if you see, I will go through these all steps here, friend, that you will get that after it takes a lot of time. Curing time is higher here in this case, hardening time. Now, I told you the advantages: lowest cost, more uniform density, uniform shrinkage due to the uniform flow. What is the shrinkage? It is relaxation process of oriented molecule. If you see, the shrinkage is very low in this case, and it is uniform. Improved impact strength due to the no degradation of the fibers during the flow. Dimensional accuracy and stability. Internal stress and wrapping are minimized. See, the compression molded article, generally they don't have a trace. The stress always create the crack. in the article, and therefore the warpage is also very less in this case. Disadvantages: touring time large, uneven parting lines present. Scrap cannot be reprocessed. Applications and products. I told you dinnerware sets you can manufacture by compression. All that tableware or dinnerware that can be manufactured by this process. Buttons, coat buttons, shirt buttons, you can manufacture by this process. Knobs, so see the railway ka knobs can be manufactured by this process. Appliance housing can be manufactured. Radio cases, automotive exterior panels, especially for the commercial vehicles, because these are the engineering polymers, thermoset materials, and therefore these polymers can be used for automobile. They have a long life, durable, high impact strength. These are the basic property of this material. Ashtray and electrical parts can be manufactured by this thermoset material by using compression process. Now, what are the advantages of this process over the induction molding process? Low scrap arising, I told you, because you are a specific type of amount you are charging in the mold. Low orientation in the molding. Here, minimum flow is there, only inside the mold. You are charging the material directly into the mold. And therefore, there is no orientation of the polymer. And that's why that shows very low orientation. If you see the injection molding process, the material pass through barrel and screw action, nozzle, sprue, runner, gate, and into the mold. So, friend, due to that, material flow from the 4 to 5, the part of the machine, and therefore the polymer chains are get oriented in case of a injection molding process. But here, there is no flow at all. The flow is there, but inside the mold. And that's why it shows low orientation. Well distributed fibrous fillers. Yes, because you are already making the tablet code molding before charging the preforma into the mold. Low residential stress product. There's no stress in the article because of no orientation. Rated in mechanical and electrical properties. These properties are very good, mechanical and electricals. In case of the article manufactured by the compressor molding process, low mold maintenance. Mold maintenance is very low in this case. Low capital and tooling costs. Tooling cost and capital. The machine has not very high cost, lower cost. Now, am I audible to you? Hello.
Yes, sir.
Yeah. Okay. Now we are going through a actual compression molding process for thermoset plastics. I told you it is a very simple process. It is the main thing is high pressure and you are providing the heat to the mold. See, I told you here in the very first diagram is the lower fixed part of the mold that is called as a bottom mold, and it is maybe cavity, it is a punch here. Okay. This is the upper platen, lower platen, and this is the ejector pin here. Simple structure, nothing is there. Therefore, predetermine the precise weight of the material. That is called as the charge. And we are also calling it the preforma. Is placed inside the cavity of the heated mold. Therefore, you have to heat this first, this part and this part. You have to heat. There may be a heaters are there, band heaters, which will supply the heat to the upper part and lower part of the mold. It is a platen. The platen, it gets insulated by the some asbestos material here. Therefore, heat is by conduction, not passing to the platen. Platen ठंडा होता है, but the mold is heated here. This mold is heated, upper part, lower part of the mold is heated. First, close the mold. That means they start the heaters to heat this mold. And after that, open this mold and put the charge here. Charge means raw material, maybe powder form, tablet form. Right. The molds are fastened to the two platen of the hydraulic press. Therefore, you have to use a hydraulic press. Even in old time, the mechanical machine was there, mechanical press. But nowadays, hydraulic press is available. You can manufacture high volume article by using hydraulic press. Therefore, once you charge the material here, the mold is then closed under the pressure. Therefore, it feeds the material between the two part of the, here the material gets squeezed, forcing it confirm the shape of the cavity. Therefore, it will take the shape of this a cavity like this. See now here, it will take this cavity. See this material, round material become this half moon type. As the pressure and mold heat increases, it polymerizes and cure the material into solid part. The mold is allowed to cool and then open to eject the formed part. The molded part may be finished or trimmed. I told you, trimming and finishing are the tertiary process. We have to use that to remove the flash, excess flash, which is formed in a processing. See now, this is a, I told you, platen, yellow platen. This is a green platen. This is a ramp here. Okay. This is a hydraulic lamp. It's a plug here. See now here is the guide pins are there. This is the mode, which also called as a punch or male mode. This is a female type of mode, cavity mode. Okay. Just the ejection here. These are the tie bars to hold the upper platen and lower platen. Same thing here. See here. complete scan structure is there. Heaters are there. 1, 2, 3, 4. See now here, mode is here. After that, see cavity is in red. The blue is punch. This is a cavity here. This is a guide pins which will hold a complete cavity. This is the mode of the machine, compression mode. And this is a machine. See, upper platen, lower platen. And this is where the mode open. See now here. The mode is in open condition. Upper part and lower part. Am I audible to you, friend? Hello?
Yes, sir.
Yeah. Now types of compression molding. Sheet molding compound and bulk molding compound. Placing a reinforcer such as a glass mat, sandwich layers of thermoplastics. Sheet molding compounds. Then bulk molding compounds. That's I told you just now. Preforma. Billet is used with the efficiently placed and distributed long reinforcement. Bulk molding compound. These are the two type of compounds we are using here. Now we will see the basic process now. See now here I told you the first step. Actually, first step to heat the mold, friend. Actually, first step is to heat the mold. This is the mold here, upper part and lower part. This is a guide pin. These are the guide pins. Guide pins which help to hold the two part, upper part and lower part. Now, see now the red part is your charge here. You are pass the material inside the cavity mold. Now, second is close the mold, more close kiya. See this charge get the shape of this. It may be dish like this. This is a dish. More close under the heat and pressure. Heat is already there. Now you are closing here by hydraulic press. And the mode is closed here now. After that, first step is mode open. Now see, the article get polymerized here. Article get QR here. Now here, open the mode and remove the article. See, the final product is like this. Very simple process, friend. Hit the mode, charge the material, open the mode, charge the material, close the mode, let the curing take place for some time. After that, open the mode, and lastly, remove the articles. Parameters. Which are the parameters? Very important in the compression molding process. The quantity of a charge. I told you 10 gram, 20 gram, 50 gram, 100 gram. We are adding there. Therefore, the first material which are charging into the mode that we are weighing first. Second thing, pressure of the molding process. The pressure may be 2000 to 3000 pounds per square inch, or maybe 13.8 to 20.7 megapascal. High pressure required to hold the upper part and lower part of the mold. In mold temperature, how much temperature? 149 to 191 degrees Celsius. Now, friend, see the thermostatic material we are processing below 200 degrees Celsius. That means 149 to 191. Maybe U up, maybe P up, right? This indicate that you are processing at a lower temperature. The chemical reaction take place, polymerization take place before 200 degrees Celsius. Cure time. Cure time means hardening time. जो chain होता है, how they get compact? What is the time to compact the chains? The period required to harden the thermoset material to partial and complete polymerization is called a cure time. Therefore, you are putting a powder or maybe pellets. Now, to convert final article while processing, therefore, that time is called as a cure time. It is also called as a setting time. It is also called as a hardening time, curing time, right? Therefore, article cure. Therefore, these are the parameters are very important. Temperature, pressure, what quantity you are adding. The mode is maybe sufficient for 100-gram material, raw material, and you are charging there 120. Then definitely it will affect the process. Lot of material will be going to convert into the flash, and that flash again you can't recycle. That is the wastage of material. Therefore, the quantity of the charge is very important. Whatever you are putting into the mold, pressure, temperature, cure time, the time required to harden the article. It is called as a cure time. Now, this is a simple frame, not hydraulic, a mechanical compression press. This is a handle here. And it's a toggle type 1, 2, 3. These are the all toggles. Their numbering are showing. And here is a upper platen, is a lower platen. And when you take this handle down, it will get close. That means it will come down up to here. This is a simple mechanical toggle type of compression molding press. Now, this is a hydraulic press. This is a hydraulic press, friend. If you see, downstroke press and upstroke press, the two type of press. Can anybody tell me this press is which type, downstroke or upstroke?
No idea, sir.
It is
But
a
here it is
downstroke.
written downstroke.
Yes, it is a downstroke because see now, this is a piston here, and see this is a platen, it is a coming down here. This type of press is available in the market because the gravitational force you are taking the benefit of that. And this press is also a danger because it is a downstroke. Many times nowadays upstroke machines are there. Therefore, this piston and this movable platen is from the down. It will go like this. That is called as an upstroke machine. This is a downstroke machine, right? Therefore, the diagram shows downstroke machine. Therefore, top platen making use of an overhead hydraulic cylinder. This is a hydraulic cylinder here. Due to that, the ram coming down, by using the Pascal's law. If you see the Pascal's law, this machine is working on the Pascal's law. What this indicates, if you keep a fluid in a closed, any type of pot, the pressure will get from the inside wall equal to everywhere. The pressure is completely equal to everywhere. And on this basis, this machine is hydraulic press is working. It's a hydraulic press. See here, pressure indicators, the buttons are there to take up, to take down, and this is the emergency button. Okay, these are all the many things are there here. This is a, if you see here, ejector pins are there. You can eject the article, and this is a cylinder. Okay, therefore, if you see the this is a bottom pattern, this is the upper pattern, right? Movable pattern. Okay, this is a upper pattern, this is stationary pattern. This is also a stationary pattern, and this is a movable pattern. Which wala? Downstroke press is generally used for a bigger and the deeper article. Article both deep रहेगा and big article रहेगा कि उसके लिए we are using for this a downstroke compression press. The upstroke press is similar in operation, except that the hydraulic cylinder is mounted beneath the bottom of the platen and moves its platen towards the fixed top here. I told you just now, like this. Upstroke press is used generally for smaller component, but not suitable for larger parts. Therefore, these are the advantages of upper stroke machine and low stroke machine. Upper stroke we are using for small article, and downstroke we are using for the large article. That is the only difference between the two. But safety point of view, the upstroke machine is good. Okay. Now see, this is the simple hydraulic. Now, can anybody tell me it is a which type of machine, upstroke or
Downstroke.
downstroke?
Upstroke.
Upstroke, yes, correct. Therefore, this is a downstroke and this is a upstroke machine. See now here is a hydraulic oil. It is a cylinder. It is a tank, and I told you it work on the that the rule. The force is get applied in a closed container, same everywhere. By using that principle, you are operating this machine, and this upstroke movable pattern goes up and up. See here, you will get a pressure, maybe in a PSI. This is a maybe, up and down like that. The knobs they have given here. Okay, that maybe ejector pins are here, and this is a maybe handle here. Now, the very basic part of the compression process is preheating. Therefore, I told you the material is in the powder form or maybe in a preform or maybe tablet form. The molding compound is at the time preheated prior to molding. आपको preheat देना पड़ता है, but preheat कितना देने का? Not 140 or 194. No, preheat maybe up to the maybe 80, 70 like that. Not very high. If you give the very high heat, the polymer start to polymerize in the heating only. Therefore, we just want to remove the moisture, and this is a lot of many advantages are available by preheating the material. Now, this is carried out with a maybe in the oven to remove the moisture, whatever the gases present in the powder, and it can be done in a oven using the infrared rays or by using the high frequency heating. Therefore, preheating is essential in a thermoset to remove the moisture, to remove the gases, and we are getting a lot of that advantage of a preheating. What are the advantage of a preheating in the process? Number one, curing become a more uniform. The curing means cross-linking. That become a uniform because you are heating the material first. You are saving the heating also in the mode. Your friend, heating is very important. Preheating. Then flow becomes more uniform and easy. If you preheat the material, raw material, then while processing, the flow will be easily, and we are not require a lot of pressure and lot of heat. You can saving the heat as well as pressure by preheating the material, raw material. Then better heat transfer because you are heating the material first. Therefore, uniform heating will be transferred. Less pressure required. Just I told you. Because you are heating the material first. You are saving the pressure here. Moisture and other gases are removed before processing. Because if the moisture and the other gases present in the raw material, that will affect the quality of the material. There may be silver mark, there may be burn mark, there may be many fault. You will not get a good shining of the article. And that's why after removing the moisture and the gases present in the raw material, you are getting a good finish, good article. You are also cycle time is low. Cycle time is that means manufacturing time is low, and curing time is also low, and easily processed by heating the uh, material. This is a very important, friend. Any question here? Hello, hello, hello. Any question here, friend?
Yes, sir.
No question? Hello.
Yes, sir.
Anybody having any question here?
No, from my side.
Okay, okay. We will proceed. Now, see the processing parameters. See, this slide shows a different type of phenolic epoxy resins, and see the temperatures. Processing temperature, see now here. The processing temperature, the pressure required. See 350, 420. If you add, this is a virgin PVC, the not PVC, phenol formaldehyde, without filler, nothing. You are not adding anything. You are adding filler to get the good dimensional stability, to get the good strength, to reduce the price of the material. These are the advantages of the filler. There are a number of fillers available in the market. Also, you are reducing the shrinkage by adding the filler. Therefore, friend, without filler, see the temperature, see the pressure. Lower, lower temperature, lower pressure. I told you. Additive ka lot of effects are there. Now see the bulk factor is a 2 to 2.5. See here shrinkage 1 to 1.2. Lowest shrinkage. Okay. If you see the shrinkage here, because it is a virgin material, you are not added a filler here. I told you, if you add filler, then lower shrinkage. See now here, the filler you are not added, and therefore this figure is showing high. If you see this below figure, because here something fillers are added, 1, 2, 3, 4, 5. But see now first one, the filler is absent here, only the virgin material is there. Phenol, formaldehyde. I will take a gap for 2 minutes, friend. 2 minutes.
Okay, sir.
Yeah. The friends, compression molding, uh, they are the basic parameters are there. Temperature, pressure, and the effect of temperature pressure on the volumetric ratio and the shrinkage. I told you what is the function of a filler in the compound. I told you there are 3 to 4 functions of the fillers. Why we are adding a filler in the plastics? To reduce the cost, because filler are cheaper. Hello, am I audible?
Yes, sir, you are audible.
Yeah. Um, Fillers we are adding in the plastics. Why we are adding filler in the plastics? Because to reduce the cost, we are reducing the suppose of one polymer or plastic. It is a 300 rupees per kg or maybe 500 rupees per kg. But the filler, if you see, 25 rupees per kg. If you add some filler, maybe 10%, 20%, you are saving the polymer cost. And then that's why you can able to sell the product with a higher cost in the market. You can get the benefit. And that's why it is not only to reduce the cost, but also to give the good strength to the article. Article get a good strength because the immunity of the article will be get that stronger by adding the filler. So friend, you are getting the strong article by adding the filler. Third thing is that reduce the shrinkage. If you add the filler in the plastics, then whatever the shrinkage, after that after creating the article dimension goes on changing. Suppose initially in the mold, it may be 5.5 centimeter length of the article. But when the article you are creating in the by using the mold, the length of that instead of 5.5, it get reduced. It get a 5.3. That is called as a shrinkage, change in dimension. Change in dimension. Therefore, friend, the shrinkage will be reduced by adding the filler in the compound. Many times, filler will help you the dimensional stability. The article get a good stability, and that's why these are the main functions of the fillers. Adding filler in the article or compound. Therefore, see now I told you the effect of filler on the volumetric ratio and the shrinkage. That is what is a bulk factor. See here, bulk factor. Therefore, if you see here, the shrinkage will be going to decrease by adding the filler. See now, either these are the different type of resins. See here, PF resin. Temperature 130 to 160, pressure is 140 to 350 kg per centimeter square. See now here, but here you are using the mineral fillers here. Phenol cresol type. Now here formaldehyde resin with a asbestos filler. By adding this asbestos filler, see here, temperature increase. Also the pressure required high, and see the bulk factor here goes on increasing. And see here, the shrinkage will be reduced. See all this by adding the wood filler. There are different type of filler. Textile waste filler. The frame, there are different, you see now, the cellulose fillers, the effect of each filler, they are shown here, frame, on the temperature, on the pressure, and volumetric ratio, and the shrinkage. By using the only one polymer, that is a phenol formaldehyde resin. They are changing only the filler here. Okay. See now. Now here the urea formaldehyde. Now we have seen here phenol formaldehyde. But now urea formamide resin, see the temperature goes on increasing 175, 145 to 160, 180. See the pressure here, and see the here the shrinkage is also going to reduce. But here they have only used the cellulose fillers, cellulose fillers. Here is the melamine resin and urea formaldehyde. These two resins are called as amino resins. What? The amino resins. These melamine resins are used for two crockery, tablewares, and UF resins are for many applications, friend. Now see here, compression molding cycle. See now how you are start the material, how you start the process. I have shown you many slides. First step is heat the preheat the material. Second step is heat the mold, right? Then create the by preheating. You have to create the palette form or maybe in the tablet form, right? Preforma. Then feeding the material can be done by weighing first, right? As well as volume wise. Feeding calls for preforming the like pelletizing to account for the bulk factor of the material. Therefore, you are reducing the volume and you are creating the tablet, right? Then closing of the mode. This is done by fast stroke first, then beginning, then before closing the mode or stroke, maybe less. You have to reduce the speed. Then breathing. After closing the mode, you have to give some breath. Breathing means up and down, up and down. Just open the mode, close the mode, open the mode, close the mode, like that. You have to open only 2 millimeter or only few millimeters. Therefore, whatever the air, steam, and other gases will escape from that two half of the mode. During breathing, the mode is open for a while and then again close. That I told you, opening and closing, opening and closing. That is called the breathing. That means what is breathing? You have to remove the gases, you have to remove the air, you have to remove the stresses or steams inside. Then after that, you have to give the time to the curing, that is hardening. The fifth is opening of the mode, open the mode. The ejection of the article and cleaning of the mode to make it ready for the second cycle. Then you have to clean the mode. Now, see the what will happen into the mode. First, you are to adding the material here. This is a more closing force. Force is here is very fast. See now here coming down immediately. They see now here temperature. Here the flow will start of the material. See, after flow start here up to here. Right. It's a time for curing. Right. Time for curing. Now curing will start from this place. See now here. The curing will start. After curing, the more closing force will increase. See now here. Okay. Now it is completely compressed here. Here the material get plasticized up to this place. Then here the flow will occur. The material gets spread inside the mold uniformly here in this time. And after that, after spreading the material, curing and cross-linking will start from here to here. Okay. Now, see here, the two diagrams shows thermoset and thermoplastic processing temperature and the time with the velocity flow. See now here, velocity of flow. Here on x-axis, time is there. On y-axis, velocity flow is there inside the mold cavity. So now see, you apply the force, right? The velocity flow will increase like this. Then after that, after some time, it will get steady because the polymer completely melt here in this here up to here. Now the flow will start up to here, and then the velocity will stop here. The flow will stop here because the curing is start. See now, this is the curing time, right? Okay, this is in case of a thermoset material. See now here for thermoplastic material, again the same thing happening. Material gets softened here, velocity flow will increase up to this. Now it become a see now steadily, complete steady as per the time. Therefore, velocity flow will decrease here. See now here will decrease. It will not increasing. The decrease here as per the time. Okay, the material get hardened in this case thermoplastic. I will show here the basic cycle of the compression press for thermoset material. See now, you have seen the machine, right? Hydraulic press. Now see now here punch is there, movement of the punch. We have seen upstroke machine and downstroke machine. Upstroke machine are used for the small articles. I told you. Downstroke machine are used for the large articles that you have seen. Now, when you opening the mode, right? When you opening the mode, what will happen, friend? Your cycle start. Cycle start. See now, A to B. What is A to B? Rapid mode closing. Fast. You have to close the mode. Then B to C up to here. Slow closing of mode until the contact with the powder. Now you are closing the mode, right? Therefore, slow now. Once it is reached to the powder, then start slowly. After that, rapid closing. G to D, C to D. See here, see, some increase. See the punch moment here. Rapidly closing. Okay. And it will compact the material. Powder को compact करेगा. Then D to E. Just keep pressure, same pressure as per the time. Right. Here is a no moment of the punch. And you are completely applied now 100% force here. Now, again, just open the mode. E to F. थोड़ा punch नीचे कर दिया. What will happen? Whatever the gases, right? Whatever the gases, you are, it's called a breathing. It's a breathing section here. That means opening and closing. Here, you are lowering the pressure. Therefore, whatever the gases, whatever the air, whatever the present there in the form of maybe fumes, that will go out. Therefore, your article will be free from the voids. Usko whole bubble form nahi hoga, right? To avoid the bubbles, we are giving breathing operation here. Breathing means what? Opening and closing the mode for some few minutes, 1 or 2 minutes maximum, not more than that. Okay, just opening, closing. Due to that, whatever the gases present in the mode, created in the mode, due to here, see now here, we are closing the mode here, right? The mode is heated and the gases will be definitely produced. That gases we have to remove. Therefore, here breathing section is there. You have to give the breathing. Closing, opening. Therefore, whatever the gases produced inside the mode will get escape. Now, after that, again close the mode. See now here, the punch go up and here the close the mode now. Right, closing after breathing. Now the curing will start. Curing means cross-linking. Curing means hardening. Curing means setting. Right. The cross-linking will be start between the chains, among the chains. After that, up to the curing will take maximum time. And then after cure the article, see you have to open the mode here. Opening the mode and remove the article. The cycle is end here up to J. Right. The opening is also slowly you have to open. It take time. See, from this place to this place. Just don't open like this immediately. You have to slowly open the mode and remove the article. This is a compression cycle graphically representation. Any question here, friend? Any question here?
No, sir.
Yeah. Okay, we'll go ahead now. So if it is now, see here in the cyclic form. See now here. See, this is again cycle of the compression mode, right? Compression mode closing. See, now mode is open. Now you are adding the material inside right here. You are charge changer over time. Now more closing material not under the pressure here. You are adding the material here. Add the material here. Right. After adding the material, mode closing will start from this place. See now, mode closing start because material is inside the mode. Now, when the material, now you are closing the mode, when closing stop, flow ceases as the mode is closed. Now see now, up to this point, this is called a gel point. यहाँ पे मटेरियल क्या होता है सॉफ्टन होता है सॉफ्ट हो जाता है मटेरियल एंड आफ्टर सॉफ्टनिंग द मटेरियल फ्रॉम दिस द क्यूरिंग विल स्टार्ट अप टू दिस curing means hardening. देखो maximum time more than 50% time required for the curing, right? And this is the bad luck. This is the limitation of this process friend. बहुत टाइम लेता है क्रॉस लिंकिंग को टाइम लगता है सेटिंग को टाइम लगता है फॉर थर्मोसेट मटेरियल आफ्टर दैट वंस द आर्टिकल क्यूअर आर्टिकल क्रॉस नहीं हार्ड हार्ड बन गया मोड के अंदर ओपन द मोड आफ्टर ओपनिंग eject the article. You have to eject the article. And this is a changeover type. If you want to change the mode or anything, जुना मोड निकालो नया मोड डालो तो चेंज ओवर टाइम बोलते हैं हम लोग उसको राइट दिस इज a cycle for the compression molding process. Now, material property affected by the process. I told you density is very important. Strength of the article, density of the article. This all depends upon the process. What type of pressure you are applying, what type of, that orientation will take place, what type of temperature you are putting, right? What type of bulk factor is there, what type of, shrinkage will be there, right? Friend. So therefore, density is very important. Strength is very important. Anisotropic property, fiber orientation. See now here, fibers are get oriented this side only. And see now, these are the all fibers, small fibers. Now, when you close the mode, that time the fiber will start to get oriented like this. And I told you, fiber means it is also type of filler. Fiber orientation take place. It will reduce the shrinkage and reduce the warpage. Therefore, article become a stress-free, warpage-free, and shrinkage-free due to the presence of fillers and the fibers. Fiber will give you strength to the article. It will increase the density of the article. And due to this anisotropic property of the fiber, therefore, they spread all over equally. And due to that, you will get a higher strength, higher dimension stability. And if you see, measure the density is equal to every place. Therefore, friend, these are the advantages of the fibers you are adding in the material. Now, bulk factor. I told you bulk factor is very important. Bulk factor varies from 1, 2, 3, 4, etc. It is the ratio of the volume of the material per kg to the volume of the same material in the product when processed per kg. Therefore, powder divided by the weight of the article. Very simple thing. What is a bulk factor? Bulk factor is nothing but जितना चाहिए जो पाउडर चाहिए जितना पाउडर you are using to make the article and that article का weight it's divided to that powder. Therefore, powder weight divided by the article weight, and that is called as a bulk factor. Now, cohesion. That is the how far the material remains as a bulk or a mass. This is called as a cohesion. कितना टाइम bulk फॉर्म में रहता है, कितना टाइम में mass फॉर्म में रहता है material. That is called as a cohesion. It is very important. Water absorption. See, I told you you have to preheat the material. The material start to absorb the moisture from the atmosphere. And that's why we are, removing all the air gases present in the material. Shrinkage. Shrinkage will, I told you, shrinkage is nothing but the relaxation process of a oriented molecule. If you apply the lot of pressure and which way. Anisotropic property play very important role in a shrinkage. Now, shrinkage depends upon the whatever pillar you are using, whatever process parameter you are using, whatever bulk factor you have, that you are taking in account. These are the contribute to the shrinkage. The shrinkage will be higher if you are not adding the pillar or fibers. Viscosity. This also play very important role in a processing. Some polymer shows made form will have the very high viscosity. I told you, ultra high molecular weight high polymer. That is a very high viscosity. Teflon, very high viscosity. The viscosity of the made polymer may be as I have 10 raised to 6 to 10 raised to 8 points. This is a number of polymer have a viscosity between 10 raised to 6 to 10 raised to 8 points. Viscosity changes with temperature, that you know very well. If you more supply more heat to the polymer, it will melt very fast. Therefore, the viscous material become a higher viscous. Okay, less viscous. Also, with the rate of flow, in most of the polymer, higher the rate of the flow, lesser is the viscosity. Right? If the material start to flow very fast, then we can say that it is a lower viscosity. If the material not flow, then we are saying it is a higher viscosity. For example, I told you, Teflon, if you heat Teflon, it will not flow. Therefore, it is a higher viscosity. Second example, ultra high molecular weight, high density polyethylene. If you supply the heat, it will not flow. Therefore, it will have a high made viscosity. You take a simple polypropylene. You heat polypropylene, it flow easily. You take a polystyrene, it flow easily. Therefore, it have a higher viscosity. You have to keep in mind all these things. Latent heat. Some polymer, they have a ability to, to, to keep heat with self. They are not easily cooled down or not easily, heated. Right? If you see the water and earth, land, see, water take more time to heat and more time to cool as compared to the land. Land is very fast heating and very fast cooling, right? But in case of a water, now if you go to the at a sea or beach, just insert your hand inside the water. The water is warm, but you now put hand on the land, it is a very cool. Therefore, I told you, water take more time to cool. Water take less time to heat. Hello, friends.
Yes,
See
sir.
the
Noting your point. Yeah.
हाँ, सी द कन्वेक्शन कन्वेक्शन कैसा होता है? रात को देखो हवा कहाँ से कहाँ जाता है, एंड सुबह देखो, मॉर्निंग देखो, आफ्टरनून आफ्टरनून हवा कहाँ से कहाँ आती है, राइट? समुद्र से हवा किधर जाती है, राइट? लैंड ब्रिज और सी ब्रिज, वो कभी होता है, आपको आपको पता है, right? If the in a daytime, the immediately the land is get heated, and immediately due to the conduction, whatever the layer very close to the land, that get heated first, and therefore vacuum will created on the land. Therefore, from the sea, the wind come on the, therefore sea breeze that time in the daytime, and land breeze at the night. Now see, now at present, so whatever the air flow that is going from land to the sea, because vacuum is there now. We are on the sea. This is a convection process, friend. And the same fundamental principle we are using here also in our polymer, right? The latent, that heat. Now conductivity. Some polymer are, conductive, right? We can also increase the conductivity of the polymers by adding the metal powder. Diffusivity. It is the ratio of the conductivity to the specific heat at the constant pressure. Friend, this is also very important. Temperature of the degradation. You must know what type of the polymer will start to degrade. Right. Therefore, temperature degradation is very important. Then distortion temperature. This is also very important, friend. At what temperature the article get distorted? That is a very important. You have to see all these factors, and these are the governing factors for the molding compound. See, I have some video. I will just show you that video. 1 minute.
Sir, one doubt. Hello.
Applications of Pascal's law. Joseph Bramah designed the hydraulic press in 1795. In a hydraulic press, a small force applied on a column of liquid is converted into a much greater force available to another column of liquid connected to the first. Let us see how this happens. In a hydraulic press, there are two cylindrical tubes, A and B, of unequal area, of cross sections fitted with valves V1 and V2. These cylindrical tubes are connected at the bottom by means of a horizontal tube. These cylinders contain watertight pistons P1 and P2, which can slide up or down within the cylinder. Observe that area of cross-section of B is greater than that of A. The tubes are filled with water in such a way that the level of water in both the tubes are equal. The smaller cylinder is called the pump plunger and the larger cylinder is called the press plunger. To press down or raise the pump plunger, there is a lever arrangement with a handle. Now when a force is applied to the piston P1, it exerts a pressure on the liquid contained in the smaller cylinder or pump plunger. According to Pascal's law, this pressure is transmitted to the piston of the press plunger, and due to which the piston P2 is pushed outwards. Since the area of cross-section of the pump plunger is less than that of the press plunger, the applied force is multiplied. Thus, by applying a small force on the smaller cylinder, we can lift or compress a large weight kept on the piston of the press plunger. Hydraulic press is used for compressing bales of cotton, extracting juice from sugarcane, and for extracting oil from cotton seeds. Here you can see how a hydraulic press is used for compressing bales of cotton. When the pump plunger S1 is raised with the help of the lever, the pressure inside cylinder A decreases, and as a result, the valve V1 opens upwards and water from the tank is pushed into cylinder A. When the pump plunger S1 is pushed downwards by lowering the lever handle, the valve V1 closes due to increase in pressure in cylinder A. As a result, water from cylinder A flows to the connecting tube C. The pressure in C is greater than that in cylinder B, and therefore the valve V2 opens. The water from cylinder A is forced into cylinder B, due to which the press plunger S2 is raised against the fixed roof, and the bales of cotton placed on the press plunger S2 get compressed. Near the bottom of cylinder B, there is a tube fitted with a release valve. After the cotton is pressed, this valve is opened so that the piston of the press plunger S2 gets lowered and the water from cylinder B is released into the tank.
Hello, hello.
Yes, sir.
Am I audible?
Yeah.
See now, this is a simple principle. That is you know, due to that, what is called as the Pascal's law, right? Pascal's law. If any fluid present in the container, and if you apply the pressure at any point in on that container, the whatever the fluid gets spread inside the wall of the container at equal force, right? By using that principle, they have constructed this type of very simple hydraulic circuit, and by applying only 1 kg, that load, you are lifting the 50 kg, that load, right? This is the benefit of this law, right? Pascal's law. And on that principle, our hydraulic machine is working. Friend, hello, hello, hello.
Yes, sir. Yes, sir.
Now see the now second video I am showing you very direct compression press. See, this is a rotary type of, I told you, a rotary type of hydraulic press. And the number of tablets you are manufacturing first, to put into the, to charge into the mold, right? See how the tablet forming machine is going on here, how it work. Oh, there's no sound actually.
पैनल का पूरा टेबल का भी देखो
Friend, now you have seen the video, which it shows a simple type of a compression press. Direct automation is there, and you are here. That is a code forming. That system is there, right? There is a no heat or nothing. Is just they are just pressing the powder into a tablet form with the punch and cavities. Number of cavities are there, number of punches there, and that's why you are getting a lot of that see the production is a very fast to the automation, and you are getting the right type of that weight of that tablet. It is not there's no any variation the in the weight, and such a type of tablet we are using for the compression molding purpose. It is also called as a preforma. It is also called as what? A preforma. Yeah. Any question here, friend? Hello. Any question
No,
here?
sir.
No. Okay. Now, what are the advantages of this compression molding process? The low cost. I told you that it is a low cost machine. Then uniform density. If you see the density is uniform. If you see the injection molding machine, the density maybe varies as per the that the anisotropy. It is the orientation of the polymers. Now, uniform shrinkage due to the uniform flow. That is correct. If the uniform flow is there, you'll get a uniform shrinkage. Improved impact strength, right? Because if there is a uniform flow, all the chains are get uniformly arranged, and therefore there is a very good impact strength, dimensional stability or accuracy you will get by using this type of a process. Internal stress and warpage are minimized. I told you already. Stress and warpage are depends on the shrinkage, and therefore they are completely minimized at very root level, short cycle time, and high volume of production. Disadvantage is curing time is large that we have seen in the cycle, and even parting lines present. Scrap cannot be reprocessed because it is thermoset material. How can you expect that you should reprocess this material? Because here is again a different type of bond is take place. It is called as a chemical bond. It is also called as a covalent bond. And once there's a covalent bond formed in between the chains, among the chains, it is not possible to break that bond, friend. In thermoplastic, there's a physical bond. There is a physical bond. There's no chemical bond. There's no covalent bond. But in the thermoset material, when the material become a cure, when the material become a hard, when the material set, there is a completely coherent bond present. Or the covalent bond is also called as a chemical bond. And therefore, this chemical bond never break. Therefore, you cannot recycle this material. Okay, you have to keep in mind high initial capital investment because the machine is costly. Machine is very costly, and that's why you have to uh, pass this thing. See now here in the compression, this is a compression press. See now here, and these are the articles. These are the operators are there. See that each have a one machine here, and the jigs are here, right? They have removed the article. Now there are number of flashes, right? Flash is there. Now they are removing the flash by knife. See now here, everybody is removing the flash. These are the new articles are there, and they are just checking that flash killer. Flash means what? Excess material. Excess material. If the temperature is very high, pressure is very high, therefore there may be a shrinkage. No, there may be flashes. Flash is present in the mode. Right. We are going to study about the mode also. But friend, this is a large scale compression molding press, a big one. And see these are article 1, 2, 3, 4, 5. These are all workers are there. And they are removing the flash of the article. Right. Now, application. I told you, what are the application of a compression molding process? Dinnerware, buttons, knobs, appliance housing. See here, all fridge part हम लोग रखते हैं अंदर. Right. See these appliance. See these are all the things are you can manufacture by using the compression molding press. Now, what are the troubleshooting actually? What is the troubleshooting in the uh, compression molding press? Can we cover this topic tomorrow, friend? Hello? Hello?
Yes, sir.
Am I
Sure,
audible?
sir.
Yes, sir. We can cover.
Hello,
हाँ,
sir. One doubt.
yes.
In compression molding, like let's suppose you mentioned SMC, sheet molded composite, right?
Pardon, please.
In compression molding, you mentioned SMT, sheet molded composite, right?
I'm not getting you. The sound is breaking.
Can you hear me now?
I'm not getting a proper, that you are.
Now can you hear me?
Yes.
In compression molding SMC process,
Ha,
for each part, what is the cycle time?
ha. Time depends upon the thickness of the article. Hello.
Okay, let's suppose if it is a 3 mm thickness or
Ha.
3 mm thickness compared to injection molding, what is the time of compression molding? If I talk about in terms of time, yeah.
No. Time require very high. If you 3 mm article is there, the time is it will take a more time. If you compare with the injection molding process, injection molding machine a very few seconds it will get pure, cool. But if you see the
Okay.
thermostatic machine, 3 mm it will take a more time. Maybe
Okay,
at least.
got it.
Yes,
And,
yes.
And what is the minimum thickness limit we can make through compression
You
molding?
can. Yes, 1 mm, 2 mm, 2.5 mm.
Are you sure
Yes.
we can make 1 mm? Because as per my understanding, in SMC,
No,
that
SMC is alert. No. You are talking about the SMC, sheet molding compound.
yeah. SMC.
That you can 1.2 to 2.1, 2.3 you can increase the tank. But if you see the without fibers, without fibers, you can decrease the thickness also. 1 mm also you can manufacture.
No, okay. Currently, my point is that SMC, that sheet molded composite. So, what is
Yeah.
the minimum thickness we can achieve?
No, you can achieve that maybe 2 mm, 3 mm, 4 mm, 5 mm. Nothing. Nobody will stop you.
You are telling a minimum we can make 2 mm part, right? Through SMC.
No, that is a bulk molding compound.
I'm
Hello?
talking about compression. I'm talking about compression molding.
Yes. But sheet molding compound, you can manufacture, at any thickness.
No, I agree. Up to we can make, but I'm talking about lower limit. So, what is the lower limit?
Lower limit for the sheet molding compound.
Yeah.
It depends upon the thickness of the fibers. Hello?
That's what is the limit? If I want to make based on the current available technology available, what is the minimum thickness I can make the part?
No, thickness, you can, it is a very, it depends upon the process actually. Hello? And what type of epoxy you are using? Epoxy, PF resin, UF resin, what type of resin you are using?
Okay, I'm giving the polyepoxy resin.
Acha, okay. That
And
we have
glass
to.
fiber reinforcement.
No, that we have to check up then. If you are talking about that, then we have to check up.
Or okay, if I talk about, maybe you can let us know tomorrow. I want to know because sometimes we are making SMC part. So up to which minimum thickness I can go? That is my doubt.
Yeah. Okay.
Because
Okay.
it should not like that. I went
what-
less thickness.
what material you are using?
That SMC sheet molded composite.
But polyester.
Yeah, polyester epoxy resin. Yeah.
Okay.
And one more thing, if I compare in terms of cost point of view, compared to injection molding, so which one will less more costly, part cost, or overall kind of?
No,
That I want to
injection molding is always good, right? Injection molding is always better as compared to the compression.
Okay.
Yeah.
Then
But
why
you
we are going for comparison?
but you want to that more strong article, low
Okay.
shrinkage, low warpage, quality article, then you go for the compression molding. Yes.
Okay.
Durability. If you want to durability, then you think about the compression.
And regarding tooling point of view, I think generally we need more strength, right? Compared to
Yeah.
sheet metal, where we need more strength, and that plastic, formability like plastic part, we are going for SMC. Like we are getting strength equivalent to sheet metal, and formability like plastic part, and multiple parts we can make like sheet metal. We have to weld many parts. So single part we can make SMC.
Yes, correct.
So in terms of if I compare tooling cost point of view compared to sheet metal or compared to compression molding, which one will be cheaper cost point of view
No, compression molding is cheaper then.
compared to apna press mold sheet
But
metal?
time consuming is high.
Right.
Yes.
Okay, sir. And one more thing, sir. Can we get the now today is the first lecture of our this processing of plastic? Can we
Yes,
Can we get a complete syllabus or through mail? Because earlier we received for
No,
processing.
no. That thing you have to ask the organizer. Okay, I am just giving the
we'll
lectures
ask.
here.
Okay,
Yeah.
I will mail them.
Okay.
We'll mail them.
Yeah. It is in their hand only. Okay.
Okay, tomorrow what topic we are going to cover?
Tomorrow at 6:30.
What all topic you are going to cover?
We are going to cover compression molding as well as transfer molding.
Okay, transfer molding.
Yeah.
Okay, sir. Thank you, sir.
Yeah. Bye. Good night.
Good night, sir.
Anybody having any question, friends? Hello.
No from my side. No from my side, sir.
Okay. Thank you very much, friends. We will meet tomorrow, right?
Thank you, sir.
Yeah. Good night.
Good night.